Okay, so like I said, we're going to finish up this section. And the last piece here I know is the ones that you struggle with a little bit, but we have to do it. And that is when you have some sort of a word problem. Okay? So we'll work through a couple of examples of a word problem. I'll get out of your way in a second. All right, so this is a pretty basic idea. You know, of course, that there's two different ways to measure temperature. Were you aware of that? Yes? Okay, you've got Celsius and you've got Fahrenheit. Which way do we use in this country? Fahrenheit. Where are some places that use Celsius?
Canada.
Canada. It's really everywhere else pretty much but us. Canada, Europe, all over the world mostly uses Celsius. I'm not really sure why we use Fahrenheit, but what the heck, that's what we do. Okay? So you can figure out a formula to convert in between the two things so that if somebody tells you the temperature in Celsius, then you can figure out what that temperature would be in Fahrenheit to find out if it's hot outside or not. And that formula is this guy right here. Okay? 1.8 C plus 32, and the C stands for Celsius. Okay. Does anybody know why this word is capitalized? Blank. And what is proper about it? You're correct.
It's a name.
It's a name. Yes. The person who made up this scale was there was a person, and that was their name. Same thing with this guy right here. Okay? So both of those technically are written with capital letters because, like you said, it is a proper noun. Okay? All right, so now what we're going to do is we're going to use this formula to change some things into Fahrenheit. And this first one you might know the answer to already. The first one they want us to do is take the freezing point of water. What's the temperature that water freezes at in Celsius? Does anybody know?
It's negative 16 Celsius.
No? Nobody knows?
I know in Fahrenheit. Well, you could, we can start up and whatever it's called.
The temperature is 0 degrees Celsius. Okay? And so the person who made the Celsius temperature scale thought it would be easy to make the freezing point of water be 0 and the boiling point of water be 100. And that's a nice, easy thing to have in between. Well, let's use this formula here to figure out what the freezing point of water is in Fahrenheit. So what do I do with the 0? Same thing as we were doing yesterday. Yes? Right, so the first thing I'm going to do is I'm going to replace the C with a 0 so that I can multiply it by 1.8. Okay? So all this is what we were doing on Friday, where you start out with a formula, and then you're going to plug in numbers for the variables and figure out what the answer is. The only thing that's different is they're throwing all these confusing words at you. Okay? You need to focus in on the formula part because that's the piece that you're going to use to solve the problem. So all this other stuff isn't really necessary. You can just look at this and go, well, 0 is my C. So I'm going to replace this C with a 0 and then do the problem. So what is 1.8 times 0?
0.
0. And then 0 plus 32 is what?
32.
32. So what's the freezing point of water in Fahrenheit? 32 degrees. Okay, so that was a pretty easy one. Let's do another one. Like I said, the boiling point of water in Celsius is 100 degrees, and that makes it a nice, easy scale to use. But the scale that we use does funny things. Okay, so first of all, the freezing point of water is 32 instead of 0, so that's kind of hard to remember. Now let's figure out what the boiling point of water is in our Fahrenheit scale. So once again, we have that formula 1.8C plus 32. Where does the 100 go? Where does the 100 go, Austin? Yep, goes in there for the C after the 1.8. So I'm going to rewrite this as 1.8 times 100 plus 32. Okay, what is the easy trick in multiplying a decimal by a power of 10, like 100 or 1,000 or, yeah? Move the decimal over how many places? Why 2? Because there's 2 zeros. So I'm going to take this and move it over once, which would make it 18. And if I move it over another time, what do I get? 180. I have to add a 0 in there because there wasn't enough room for me to move the decimal over. So 1.8 times 100 is 180. Then I have to add the 32. 180 plus 32 is?
212.
212. Okay. So in Fahrenheit, the boiling point of water is 212 degrees. So that's kind of awkward, but that's what we use and that's what we're stuck with. Okay? All right, let's do one more with this same formula. The highest recorded temperature in the United States was 57 degrees Celsius. Let's see how warm that is, because when you say 57 degrees Celsius, does that really, to me, it's like, I don't have a good sense of if that's super hot. I mean, they told us it's the highest one, so it must be super hot, but I don't really know. So once again, what do I do with that number?
You multiply it by 1.8.
I multiply it by 1.8. Good, so I have to go 1.8 times 57 plus 32. So this multiplication is a little bit trickier, so we'll do this off to the side. 8 times 7 is? 56. So I write down the 6 and I carry 5.
40.
8 times 5 is 40, and then I have to add the 5 onto there, which is 45. Very good. 1 times 7 is 7. 1 times 5 is 5. So if I add those up, do you guys put a 0 there when you do this? You do?
Yeah.
Okay. So I got a 0 right there. So 6 and 0 is 6. 5 and 7 is 12. Carry the 1. And that is going to be 10. Okay, so that's pretty hot. 1,026 degrees. Oh, 102.6.
Yes, yep.
Yeah, that doesn't seem very hot to me.
Really? Well,
Yeah.
110 miles a day.
Yeah, see, so how could this be the highest temperature ever recorded in the United States?
Oh, no, it's not.
It's not. What did we do wrong?
Multiplication.
No, we did the multiplication correctly.
The formula. Forgot to add.
We didn't add the 32 yet. That was just the first part. So this is 102.6. But then I have to go plus the 32. Okay? What's 102 plus 32? 134. Now we throw the 0.6 on the end, and now we are talking about a pretty hot day. 134 degrees. That's a little warm for me. Okay?
Multiplying the stuff out.
What's that? Everything or just the multiplication part? Okay, well, we're just going to have to keep working on it, okay? Take one step at a time, and when you do one, you'll come up here and check it with me, and then we can work through it, and then, you know what I'm saying? We'll get you figured out. Okay? All right, so let's kind of sum up what we have going here. If someone would raise their hand and give me an example of an algebraic expression. That was the first thing that we talked about on Friday. Matthew, give me an algebraic expression.
32b.
32b, nice and simple. Okay, good. You said what?
B.
A Oh, V. V as in vulture. All right, 32V is an algebraic expression. Very good. Somebody else give me another one. Austin.
33B.
33B. All right, things are getting tricky now. Good. Blaine.
1000P.
1000P.
Billion.
Okay, what is it about all of those things that make them algebraic expressions? Benjamin? Okay, they have a variable in there. Okay, and I could also keep this as an expression if I decide to add those together or subtract them or multiply them like that. Okay? All right, somebody else who we have not heard from, raise their hand and tell me, give me an expression that is not algebraic. 3 plus 3. Okay? Why is that? Yeah, thanks. Why is, yes. You give me that? Okay, or 2 plus 2 and so forth and so on. And right, there's no letter in there, so these ones are algebraic and these ones are not. Okay, good. So hopefully you all understand that. All right, so tell me if we started with this top algebraic expression and I told you to evaluate it for v equals 2, b equals 7, and p equals 1.5. Somebody tell me how I would do that. Don't do it, but tell me in words how you would evaluate that algebraic expression.
Can we write that down?
No, we don't have to. We just have a little discussion now. Jake, do you have any idea how you would evaluate it? How would I evaluate this algebraic expression? If I start with this, and then I'm told that b equals 2, b equals 7, and p equals 1.5. I'm just going to work with Jake right now. Okay, right. And so what would I multiply? 32 times 2, because I'm going to plug the 2 in for that. And then what do I do with the 7? Multiply it by 33, because I'm going to plug it into there. And then what do I do with the 1.5? Multiply it by 1,000. Okay, very good. All right. Tell me why I could not find an answer to this problem right here. 4x minus 5y, and I want to evaluate that for x equals 3. Why can I not find an answer for that? Yes.
Don't you need a number for y?
Yes, in order to evaluate this one, I would need to not only know what x is, but I would also need to know what y is. Okay? All right, we good? Okay. So again, homework on a separate sheet of paper. You're going to keep your notes. Homework you're going to turn in every day. Make sure you put that on a separate piece. Yes, sir.
Do you have like your personal account or like this one?
Just this one.
Mr. Aldridge,
Yeah.
for Friday, what kind of notes did you take? Because I had evaluating algebraic expressions.
That's the one.
Okay. I can take that.
Good deal.
Go out there.